Hello 108 class, Mr. McHugh back here with you on section 7.3, and we are going to go ahead and tackle page 3 of our class notes. And we're not learning anything new here, just gonna help us decide between picking methods 1 or 2, and I made a big deal about this in the other 2 videos here for page 1 and 2. So we're not really learning anything new, but we'll get a good example, good practice on doing examples with a little more complexity to them. Okay, so you know my recommendations, you know the drill. When you have single fractions or rational expressions in the numerator and the denominator, use method 1. And remember, you're looking for a single fraction bar. If you see 2 fraction bars, this would be like the frame of it. Up in the numerator, denominator, you use method number 2, which you're going to multiply by the LCD. Over here, you're going to multiply by the reciprocal of the second rational expression in the denominator. Okay, so let's just go ahead and get right into example 3a here. So here we go. You look at this, you see 2 divided by x minus 3, all divided by 5 divided by x squared minus 9. Okay, what method are you going to use? Count your fraction bars. How many do you see? 1. Therefore, you're using method number 1. So you're going to take the numerator, the RE in the numerator, 2 divided by x minus 3, leave it alone, and multiply by the reciprocal of the second rational expression in the denominator. Now look what I did here. So I put x squared minus 9 up in the numerator, divided by 5, and I factored it. I saved myself a step here. I saw x squared minus 9 as difference of squares, so I took the square root of x squared, square root of 9, and you know the drill, so it's x minus 3 times x plus 3. Okay, there you go. Now ask yourself, can I simplify by finding any factors stacked on top of each other? The answer is x minus 3, numerator denominator equals 1, so you're left with 2 times the quantity x plus 3 divided by 5. Okay, now you want to leave your answer like this in factored form. Okay, so there we go, that's not too bad. And now we look at example 3b, and what are we dealing with here? Okay, so you guys help me. Notice I'm counting what? Fraction bars. How many do I see? 2. What method should I use? Method number 2, which is what? Multiply by the LCD, and you want to quote clear out the fractions up in the top half, bottom half. Okay, got to do a little work, got to figure out what? The LCD. Look at each denominator. X and a y must be part of the factors. Look at the next denominators. X squared, y squared, they must be. When you figure out the LCD, what are you going to pick? Remember, when you got the same base, pick the higher exponent. So there's why we put x squared. Look at y to the first, y to the second, pick the higher exponent, bingo. That's the LCD. To show the work, I multiplied both the top half and the bottom half by x squared times y squared. If you want to put that over 1, that's fine. I hope you see that. Some students again might turn around and write x squared to y squared next to each of these here. That's up to you. I happen to just, probably on the board I might have done it that way, but here I'm just going to use the distributive property twice. Okay, so let's just move this down just a little bit. Okay, so let's look at the details. You're taking x squared y squared times 1. Boom. That's what you get. Same thing over here on the numerators. I left the x and the y's here. I just want to show me multiplying them out. Now I have x squared y squared again up in the numerator because you're multiplying it by 1, multiply by 1. Now I'm ready to clear things out. Okay, so I'm going from this step over. And so let's watch the detail. X squared divided by x leaves you what? X times y squared. Y divided by y squared leaves you y, so I've got x squared y. Now down to the denominator, the bottom half. X squared divided by x squared leaves you y squared. So everybody seeing where these are coming from? What's happening over here? Y squared divided by y squared cancel out, leaving you minus x squared. Okay, so that's the beauty. When you multiply by the LCD, you see the fractions or the REs are gone. Okay, but you're not done. You might want to make this your answer. Then you go, did I factor? Did I factor? Did I factor? Down in the denominator, I see x squared minus y squared, and I could factor with difference of squares over here. Can I pull out a GCF? And the answer would be what? X and a y could come out. So there it is. There's the GCF in the numerator. X times y. What's left? Multiplied by y plus x. Again, if you take this, multiply them, you'll come up with this result. Down here, I took the difference of squares. Sorry, I'm working backwards, by the way, here. I ran out of space. I like to work vertical usually. Factor the difference of squares, y minus x times y plus 1. That's a mistake. That's an x right there, sorry. And now you're going to go ahead and cancel out. Like factors on top of each other equal 1, and you're left with xy divided by y minus x, and you're done. Okay, hey, we finished page 3, so I'm going to sign off for now. We got one more page to do in section 7.4. I'm going to do with negative exponent, so we're going to work on that. Okay, Mr. McHugh, going to sign off for now, and I'll see you later. See you on page 4. Okay, goodbye.